I am Raymond Lee, and I am working on the Big Bang Theory website for DigiScience. Today I am interviewing Byron, the physicist of the University of Washington, and he is going to introduce himself.
Okay. I'm Byron MacKenzie, a physicist here at the University of Washington. My areas of specialty are relativity and nuclear physics. I guess you have some questions for me.
Yes. Do you believe in the Big Bang? Why or why not?
I do believe in the Big Bang, mostly because of the work of Einstein and Hubble, which we'll talk about later.
What do you specialize in concerning physics?
Well, I've already stated what my specialties were, but I'll restate them as nuclear physics and relativity.
Can you tell us about nuclear physics involving stars?
I can't. There's actually two different periods of interest when it comes to the nuclear processes inside of stars. Early on, when the stars first condensed, the only element present was hydrogen. So the stars that condensed were huge, hundreds of solar masses. What ends up happening though is once the fusion process starts, heavier elements show up. And as it turns out, when stars reach a period where carbon, nitrogen, and oxygen are present, the whole dynamic of the star changes. And the reason is the three elements that I just named are what are known as nuclear catalysts. What that essentially does is it increases the amount of energy produced in the fusion process. Okay, now, so here we have now this huge star that initially wasn't fusioning very effectively, now is fusioning at a much more rapid rate and producing a lot more energy. So the star becomes unstable. After about 1,000 years, okay, which is really short-lived for a star, it typically blows up, or in what we call a supernova. And all of that material that was created is blown out. Since stars spin, it's typically blown out along a plane. And essentially this is at the stage where that star is on its first stages of forming a galaxy. Now what ends up happening, now present in the universe we have the three elements that I named, carbon, nitrogen, and oxygen. And what that does, this allows for much smaller stars to form. Stars anywhere from 0.1 solar masses on up to typically these days, I think like 5 or 6 solar masses. But obviously much, much less than that very first star that was required to put it all, to get it all started. Okay. You get the idea?
Yeah.
Okay.
What is a nova and what causes it?
Okay, a nova, there's three classes of nova. The first class, when the star, okay, I'm going to back up a step. Novas occur when stars reach the end of their life. Okay, for small stars like roughly our size, when they nova, they form white dwarfs. Okay. The next higher level of stars, typically around 2 or 3 solar masses, when they nova, they form neutron stars. Okay, neutron stars are very strange. What ends up happening is the gravitation in a neutron star is so high that the electrons and the protons overlap. So they essentially act like a neutron. So the whole neutron star is essentially acting like one very large neutron. And the gravitational field must be immense. So immense that if anything got close, it would just end up being absorbed by it. Then the largest stars, supernova, and form black holes. Okay, and a black hole is effectively a tear in the universe. In other words, the gravitation becomes so strong that the escape speed is greater than the speed of light. anything that goes into what we refer to as event horizon, which is a point of no return in the black hole, will never escape, including light. So,
All right. Who is Edwin Hubble, and what is a Doppler effect for light?
okay, Edwin Hubble was the one who figured out that the universe was expanding. And he did that by borrowing something that Einstein showed in his theory of relativity, which is known as redshift. He figured out that the distant galaxies were redshifting, which means that they were moving away. And redshift and blueshift is a tenet of the Doppler effect for light, which Einstein figured out from his theory of special relativity. But anyway, so if something is moving away, we say it redshifts. And if something is moving toward us, we say it blueshifts. And essentially what that means is the light is more energetic from a galaxy that's moving towards us and less energetic if it's moving away from us. So it turns out he observed that all of the distant galaxies were redshifted. And the farther away they were, the more they were redshifted. So the implication was that the universe was expanding.
What theories of physics supports the Big Bang?
Okay, the one I just named from Hubble and also Einstein's theory of relativity. If you look at Einstein's theory of relativity, the first paper that he produced was the theory of special relativity. Then he wrote one later, which he called the theory of general relativity. And it's the theory of general relativity that basically states that the universe cannot be static, which is to say it cannot be of a single size. It has to be either growing or shrinking, but it cannot be static. And then Hubble came along and showed that of the two, the universe appears to be growing.
How does discovering the Higgs boson affect physics?
Okay, there's two things. The Higgs boson is of interest to theoreticians who are interested in the Big Bang, simply because it was the point in which matter first came into existence in the early universe. Prior to that, the universe was pretty much a homogeneous distribution of energy. After that, certain discrete aspects of the universe that we're used to now came into existence. It's also of interest to physicists in that it was the last of the quantum mechanical particles to be discovered. Basically, quantum theory predicted a certain number of particles, and up until a short time ago, as in earlier this summer, the Higgs boson was the only one that had never actually been observed. Since it was discovered at the CERN laboratory, it was the last one to say quantum mechanics pretty much has to be right.
What are the forces in physics?
Okay, there are four principal forces in physics. Okay, probably the one that's best known is gravitation, and gravitation is the force between two masses. Okay, it's a mutual force between two masses. The next most common is the electromagnetic force, and the electromagnetic force is forces between charges. And what we do is we typically say that there are two charges, which we call positive and negative. Like charges repel. So if it's positive and positive charge, they'll repel from each other, or negative and negative, they'll also repel from each other. And then we say that unlike charges attract. So a positive charge and a negative charge will attract. Okay. The next force of interest would be what we call the strong nuclear force. And the strong nuclear force is what holds the nucleus of an atom together. And the general belief is that the source of the strong nuclear force is the neutrons. If you look at all nuclei, they have protons and neutrons. And in order for it to be stable, the neutrons have to be there. except for hydrogen. Hydrogen is the only one where neutrons are not required. Now, then the last force of interest to physicists is the weak nuclear force. Okay, and the weak nuclear force explains why some atomic nuclei are not stable. Okay, in other words, they go through decays. So if you look at, especially say very heavy elements, they tend to decay, and as they decay, they become lighter and lighter. So like uranium will eventually decay into lead. But that's not the only reason why something might decay. The point is, though, it explains why unstable elements eventually have to decay into something else. So,
What is dark matter and how does it work?
okay, dark matter is something that's overall not well understood by physics or astronomy. We know, though, that it has to be there based on how orbits are inside of galaxies. If you were to look at all the matter that's visible, then the orbiting patterns don't work. So if we add matter which at this stage is unseen, then the orbiting patterns do work. And we just refer to that as dark matter. And as I said, at this stage, we really don't know what it is yet. As time goes on, I think we'll figure it out.
Okay, thank you for your time, sir.
Yeah, okay, thank you.